In this section, we're looking at our binomial theorem. Our binomial theorem describes the expansion of a binomial x plus y to the n power. Here we get the first term is always being raised to the n power, and at the very end we have the last term being raised to the n power. We will notice that the exponent on the x and y, in this case y to the 1 and n to the 1, n minus 1, always adds to give us the exponent here. So here we have n minus r, plus r will still give us n. Here we have x to the 1 and n minus 1, which still add. So the exponents on the variables will always add to give us our n. We notice also that for the exponent on the x is decreasing and the exponent on the y is increasing. This is our binomial coefficient. We find our binomial coefficient, and it's written as n combination r, or it's written like this, which means n factorial over n minus r factorial times r factorial. Now here's a summary of what we were just talking about in our binomial theorem. The expansion of x plus y to the n, there will always be n plus 1 terms. So if n is equal to 2, then we will have 3 terms. If n is equal to 3, then we'll have 4 terms in our expansions. The expansion is symmetrical in terms of the x and y. The powers of x will go down and the powers of y will go up. So if the first, this is to the 4th power, then this will be, the first term will be x to the 4th, then the next term would be x to the 3rd, and then x to the 2nd, and x to the 1. And the powers of y will increase accordingly. The sum of the powers is n, so the powers on x plus the powers on y should always be equal to n. And the coefficient increase and decrease in a symmetrical pattern. So our coefficient will be from 1, and then it goes up, and then it goes back down in a symmetrical pattern. Before we start to expand our binomials, let's look at trying to find our binomial coefficients. Here we have 8 combination 6. According to our formula, this is 8 factorial over 8 minus 6 factorial times 6 factorial. This simplifies to give us 28. What this means that in our binomial expansion, the 7th term, it's always one more than this, the 7th term, the coefficient of the 7th term would be 28. Here, this is saying the coefficient of the 21st term is 1, since this is 20 factorial over 20 minus 20 factorial times 20 factorial. If you remember in our previous section, 20 minus 20 is 0, and we said 0 factorial the same as 1, so 20 over 20 is also 1. So all this simplifies to give us 1. So the coefficient of the 21st term would be 1. Here this is saying we're going to find the coefficient of the 7th term. So we have 10 factorial over 10 minus 6 factorial times 6 factorial. All this simplifies to give us 210. So the coefficient of the 7th term in this expansion would be 210. An alternative to finding the binomial coefficients would be to use Pascal's triangle. Pascal's triangle is an array of numbers. We start with 1, and if we branch this out, we have 1 and 1. If we continue 1, when we combine the terms here, we have 1 plus 1 is 2, and 1. We can continue 1, 2 plus 1 is 3, 2 plus 1 is 3, and 1. 1 and 3 will give us 4, 3 and 3 will give us 6, 3 and 1 will give us 4, and the ends are always 1. So we have 4 and 1 is 5, 6 and 4 is 10, 6 and 4 is 10, 4 and 1 is 5, and 1. And we can continue all the way down. And what we realize is that when we get to the 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8 row, we notice that the 7th entry is 28, which is exactly what we found using the theorem for the combination. So 8 combination 6 tells us that in the 8th row, our coefficient of the seventh term will be 28, which is exactly what we got using Pascal's triangle. And these are just the coefficients of any row. So for the first row or the 0 row, then our coefficient would be 1. For the first row, our coefficient would be 1 and 1, since if we expand this, we have 1 and 1. For the second row, our coefficients would be 1, 2, 1, and if you multiply this out, you'll see our coefficient is indeed 1, 2, and 1. And so Pascal triangles give us our coefficients of our binomial expansion. This is an alternative to using our combination of, and we still, however, get the same results, 28 or 28, which is the 7th entry in the 8th row. In this example, we're going to use our binomial theorem to expand and simplify the binomial x plus 1 to the 6th power. So here we have x plus 1 to the 6th power. We know that our first x term will be to the 6th power, and we know every term after that the x will be going down. So we start with x to the 6th, the next term will have x to the 5th, then x to the 4th, x to the 3rd, x to the 2nd, x to the 1, and x to the 0. We also know that the 1 here, which represents our y, will also increase in terms of exponent. When x is equal to the 6th power, then this value should be to the 0 power. If you recall, the sum of these two exponents must always be equal to 6. So here we start with a 1 to the 0. This becomes 1 to the 1, and these two is equal to 6. This becomes 1 to the 2nd, and these two is equal to 6. 1 to the 3rd, and we add these, become 6. 1 to the 4th, 1 to the 5th, and 1 to the 6th. So here we have expanded the x, we have expanded what was our y in our theorem, which is now 1. And now it's left for us to find our coefficient. The first coefficient will be 6c to the 0, then the next coefficient will be 6c to the 1, since our exponent is 6. This will be 6, and then our 0, 1, third, 6c to the 2nd, 6c third, 6c 4, 6 combination 5, 6 combination 6. Here's just a matter of simplifying these. We can either use our scientific calculator, we can use our Pascal's triangle, or we can use our factorial. But 6 combination 0 is actually 1. So this becomes 1 times x to the 6 times 1, since 1 to the 0 is 1. So the first term just reduces to x to the 6. Here we have 6 combination 1, which is the equivalent of 6. We have x to the 5 times 1 is still x6 x to the 5th. Here we have 6 combination 2. This is 15 times x to the 4th times 1 is still 15x to the 4th. Then we have 6 combination 3. This is 20 times x to the 3rd times 1, still 20x to the 3rd. Then we have 6 combination 4, which is 15x to the 2nd times 1, still 15x to the 2nd. 6 combination 5 is 6, so we have 6x times 1, and then 6 combination 6 is 1, x to the 0 is 1, 1 to the 6 is 1, so 1 times 1 times 1 is 1. So here we have the complete expansion of x plus 1 to the 6th power.